Welcome to another video. My name is Thijs, I'm the technical evangelist at Varnish Software, and in this video I'll highlight 4 Varnish Enterprise features that will take your Magento caching to the next level. If you're a Magento user, you probably know Varnish. It's the recommended page caching system, and it's one of many layers that is required to keep Magento fast. It's arguably the most impactful one because it's the page cache. It's what caches the output that is being sent to the user. And a lot of people use Varnish Cache, the open source version of Varnish, which is a great project. It's absolutely brilliant. It's super powerful, and thanks to the built-in VCL language, it's highly customizable. However, there's a couple of gaps there that are filled by our enterprise product, and today I want to highlight 4 features that are not part of the open source project and that we offer that will make a huge difference. Notably, end-to-end TLS support, natively supported in Varnish, automatic memory management, powered by Varnish Enterprise's memory governor, tag-based cache invalidation, natively supported with the soft purge option, and dynamic backends that also support DNS-based load balancing and service discovery. I'm going to cover those features and show what type of value these features bring to your Magento store and your organization. And then we're going to do a deep dive where we're going to look at the individual features and how to implement them into your Varnish and into your Magento store. So without any further ado, let's go for it and let's have a look at end-to-end TLS. Because in the open source version of Varnish, you require the use of a TLS proxy to offload TLS and to communicate with Varnish over plain HTTP, because the open source version of Varnish doesn't support native TLS. There's a variety of technologies at play. A lot of people use Nginx or HA proxy, or even our own TLS proxy that we've open sourced that is called Hitch. And while that works fine, it adds a layer of complexity, where you need to configure the TLS part in the TLS proxy, communicate from the client to the TLS proxy first before hitting Varnish. There's a variety of configurations that are required to make this a smooth process. And in Varnish Enterprise, we eliminate the need for a TLS proxy, which means you can connect directly to Varnish, both over port 80 and 443 for plain HTTP and HTTPS. The business value of using our native TLS implementation is the fact that you no longer need a TLS proxy. There's no more offloading of TLS. Everything happens within Varnish, from configuring the listening endpoints to all the cryptographic settings to registering the certificates. No longer needing a TLS proxy means one less component to manage. It means less configuration and less things that can go wrong. And if your TLS proxy is hosted on a separate machine, you have the ability to reduce your infrastructure footprint. And from a security perspective, you have an end-to-end encrypted solution, which is not supported by the open source version. While open source supports offloading of TLS, the connection between Varnish and your backend, Magento in this case, is still happening over plain HTTP. And that's where we have a clear advantage with Varnish Enterprise. The memory governor feature has such a nice ring to its name that I had to create the following visual. Forgive me for that, but the name already implies that this memory governor actually governs the memory. It manages the memory and keeps a constant memory footprint. Because a typical challenge in open source is that you allocate a set of memory for object storage, which you can set with the -s runtime parameter, but there is also a runtime cost when you use Varnish, and the memory governor tries to keep that constant. So allow me to illustrate that with a very common use case. Let's say you have a server with 90 gigabytes of RAM. 80 gigabytes is allocated for storage, and maybe you leave 10 gigabytes as headroom. But there's a runtime cost as explained. So maybe there's object overhead. Of course, the object overhead is in the mere kilobytes, but if you have millions of objects, that will account for some storage. There's also workspace client memory, memory that needs to be allocated to handle threads and incoming requests. The more concurrent requests you have, which is really a luxury, it's something you need, this means you have a lot of visitors on your Magento store, well, that allocates some memory as well. There's also a thing called transient storage, which is typically unbound in Varnish. It's storage that is used also in memory to store short-lived objects, objects that have a TTL lower than 10 seconds, but also uncacheable objects that need to be streamed from the origin, in this case Magento, to the client. It needs to be stored somewhere. It also has a memory requirement. And when you have varying traffic patterns, those requirements of individual pieces of memory will increase. You might have 6 gigabytes for transient storage. You might have 6 gigabytes of object overhead. Who knows, you might even have 8 gigabytes of workspace client. And again, it eats out of your headroom. And maybe you make this crucial VCL mistake where everything ends up in transient and you simply go out of memory. And that, ladies and gentlemen, is simply unacceptable. And that's where the memory governor shines, because it gives you that constant memory footprint, having less risk of an outage and a more efficient and predictable use of the resources on the system. The next Varnish Enterprise feature for Magento users that I want to highlight is a pretty big one. It's tag-based invalidation. That means objects can be identified using a collection of tags, and those tags can be used to invalidate those objects, which is far easier than just identifying individual objects using its URL. And that can get quite complicated if a lot of URLs are affected by a cache invalidation. And as a matter of fact, Magento already has a tag-based cache invalidation mechanism that uses, or should I say abuses, a native feature of Varnish, which is called bans. By stating the different tags with comma separation and storing them in a particular header, you can do a regular expression match using bans on those patterns. This is rather expensive from a server resource perspective. And the more bans that are added to the so-called ban list, and the more objects that should be matched, the bigger the permutation and the slower it will get. Varnish Enterprise can offer native tag-based cache invalidation, which is much faster in terms of execution, which is much more efficient when it comes to server resource usage, and that has this crucial soft purge feature. The lack of soft purging capabilities in the open source version of Varnish comes with a set of very common, recognizable challenges in Magento. When product updates take place, be it an import, a synchronization, be it stock updates or changes to the description, well, the blast radius of those cache invalidations that Magento does can be rather big. Maybe a lot of categories were affected, maybe a lot of products were affected. Those objects are effectively removed from the cache, meaning that subsequent requests to the corresponding pages will result in a cache miss and will cause latency because everything has to go through Magento again. Soft purges tackle these issues. What a soft purge does is, rather than removing the object from the cache, it will set the TTL to 0. And the total lifetime of an object is the sum of the TTL, the grace value, which is used for asynchronous revalidation and defaults to 10 seconds, and the keep value, which is there to keep objects around and defaults to 0. By setting the TTL to 0 and marking the objects as expired, you can still use the remaining grace time to return the stale content to the users, while an asynchronous fetch to Magento is happening to revalidate the content after the cache invalidation. This ensures that users aren't met with an empty cache and prevents users from having to wait for Magento to fill that up again. So besides a greatly improved end user quality of experience, you're also taking away a lot of pressure from the Magento application itself. And by using native tag-based cache invalidations, the execution of the invalidations happens a lot faster, and the footprint on the system resources is a lot less, because our YKey module that we use is a lot more efficient than whatever the open source version of Varnish offers. The next feature is dynamic backends, which is also supported by Varnish Enterprise for Magento. And it means that you can configure how DNS resolution happens at runtime, and you can even perform DNS-based load balancing. This is of course not supported by the open source version, where DNS resolution, maybe of your backend hostname, only happens once at compile time. That's the only time the DNS resolution happens. Any DNS changes at runtime, Varnish will be oblivious to, which is very detrimental to dynamic environments where there might be scale out, scale in scenarios. And these are the type of issues that dynamic backends tackle. And for organizations, it gives a lot more peace of mind knowing that you have a better resilience strategy because of dynamic DNS. You can also perform DNS-based load balancing, which greatly improves your scalability scenarios. And because of the service discovery capabilities that are in there, organizations are a lot more flexible. Definitely in this day and age of cloud, scalability, and orchestration. And that's pretty much the value we bring to your organization and to your Magento store in terms of simplicity and ease of use, in terms of runtime flexibility, and in terms of improved performance. So let's take a deeper dive and show you how these features actually work and how you can actually configure them. And I promised you that there would be a test store that we would run it on to illustrate it. Allow me to introduce that one to you. This is the Magento store that runs on my laptop in a Docker setup. It uses the magento.test domain to reach it, and it has the sample products already imported. So you can see that there's a lot of fashion items and accessories in there. There's different categories, different products, and we'll use that. Let's have a look at how to configure TLS in Varnish Enterprise. What you're looking at is the Varnish D program that will be managed by systemd probably. It has a set of runtime parameters and the -a lowercase runtime parameter is used to define listening addresses. So by default, you'll be listening on port 80 for plain HTTP. But if you want to have access on 443 for HTTPS content, well, then you need to configure the -a uppercase runtime parameter and refer to a configuration file. In this case, it's etc varnish tls.cfg. And that configuration file contains all the TLS related parameters. Its configuration syntax is inspired by Hitch, our very own open source TLS proxy. We use those same directives, but we ignore the ones that are irrelevant to native TLS. What is relevant, though, is the definition of a front end. It's the host and the port of the network interface we should listen on. So in our case, we're listening on all available IP addresses or network interfaces on port 443, which is the conventional HTTPS port. The next configuration directive is the PEM file. It refers to the location of the TLS certificate or TLS certificates. You can load multiple certificates and you can have multiple PEM file directives. In this example, we're splitting the location of the certificate and the private key, but you can combine them in a single directive. If you want to load multiple certificates from a directory, you can omit PEM file and replace it by PEM-dir, which will actually scan the full directory. If you want to limit the files that are loaded using a glob pattern, you can use PEM-dir glob and specify, for example, *.pem to only load PEM files. The rest of the configuration refers to very crypto-specific features, such as the definition of available cipher suites, supported ciphers, the TLS protocols, and a lot more. But one useful addition, though, is the definition of the ALPN protos. ALPN is short for Application Level Protocol Negotiation, and it's a way of TLS already announcing layer 7 protocols it supports. If you don't specify H2 in there, it will simply use HTTP 1.1. So it's useful to put H2 and HTTP 1.1 in there so that the consuming client already knows what protocols it could use to communicate with Varnish. On the Varnish server, you can see the results of that configuration by typing varnish adm and then the command tls-cert.list. It lists all the available TLS certificates. And you can see that the Magento.test certificate is there and is valid until 2027. There is also another way to configure TLS and load TLS certificates without relying on that TLS CFG file that was inspired by Hitch. By adding a -a lowercase runtime parameter, you can define an additional listening port. And you could in fact specify 443 for HTTPS and then annotate it with HTTPS so that Varnish knows this is TLS encrypted. And in the same way, you can actually annotate your regular HTTP listening port by explicitly specifying the term HTTP. Despite there being a listening endpoint for HTTPS traffic, we haven't yet configured certificates. You can see that when you go to the server and type varnish adm tls cert list again, there's nothing there. And when you go to the browser and try to do Magento test over HTTPS, the connection will close prematurely because of the lack of certificates and you'll get an error. So we need to configure TLS certificates in one way or the other. And since there's a tls-cert.list, there must be a way to load certificates. The varnish adm command I'm going to use is tls.cert.load. It takes an optional identifier. I'm going to choose Magento to identify my certificate, and then it takes the path of the certificate. Since my CRT file and my key file are stored in separate files, I'm just going to specify the initial path of the certificate, and I'm going to then provide the -k option to provide the path to the private key. And as you'll notice in the file name, nginx.crt, nginx.key, these are certificates that were generated by the nginx application that is connected to PHP. I'm just mounting the same files and importing them again. And when I perform varnish adm tls-cert.list, you can see that the certificate is there, but in staged mode. It's imported, but it's not yet active. So it's just a matter of calling varnish adm tls.cert.commit to commit any staged certificate. And when we list them again, you can see that the certificate is active. And this active certificate is also reflected in the browser. When we refresh the web page of our Magento.test webshop, we no longer get the error, but we actually get the sample data in our store. So we can load certificates, we can commit them, but there's a lot more to it. And if we look at the specification of the tls.cert.load command, there's a lot of additional options we didn't provide because the default values are just fine. But you have the ability to configure your cipher suites and your protocols and your ciphers. It's all there, but again, the default values do just fine. But I can imagine managing this manually for a Varnish server can get tedious, because if you spin up Varnish with these settings, you always lack the certificates and it requires manual intervention. Worry not, there's a way of automating it. So what you could do is you can create a separate configuration file that lists all the Varnish ADM commands you want to run upon startup. Have a look. This file starts with the socket.close command, preventing any incoming connections from happening while we're configuring the TLS certificates. Then we call start to start the worker process. And after that's happened, we can actually start importing the certificates automatically through the TLS cert.load command that you already know. We give it an identifier, Magento, and then provide the path to the certificate file. This cert.pem file that we have combines the certificate and the private key, so there's no need to specify the -k option. Then we call tls cert.commit to activate the certificate, and we end the script by calling socket.open to again accept incoming connections. All these commands could be stored in a file named cli.cfg, for example, and we can link it to our Varnish D runtime configuration by specifying a -i uppercase runtime parameter and pointing it to that configuration file. So whenever Varnish starts, those commands will be run and the certificates will be imported automatically. It's as easy as that. Up until now, we've only talked about client TLS, which refers to the encrypted connection between the client and between Varnish. But Varnish can also have an encrypted connection with Magento. That's called backend TLS and is the missing piece of the puzzle to have end-to-end TLS. It requires a little bit of extra syntax in the backend definition, so have a look at the following example. This is your typical backend definition in Magento, where we connect to a host over port 80, and that's done over plain HTTP. We have the possibility of switching the port up to 443 to actually connect to the HTTPS endpoint of your Magento. However, Varnish doesn't know whether to use plain HTTP or TLS encrypted HTTPS. We can do that by specifying this .ssl property and sending it to 1. This will ensure that encryption takes place. That's the last piece of the puzzle to actually have end-to-end TLS in Varnish. And there are some optional parameters that are on, that are true by default, like SSL SNI and SSL verify peer and SSL verify host. You can play around with them, you can tweak them. And that's how you configure backend TLS. Remember that memory governor feature I talked about earlier? The one that resizes your cache to keep a constant memory footprint depending on the runtime requirements? Well, here's how you activate and configure that. In Varnish D, you use the -s runtime parameter to specify the storage engine. The default engine is malloc. If you want the memory governor, you have to use MSE, which is short for the massive storage engine. It's our proprietary storage engine, of which memory governor is a feature. So then you could switch up your runtime configuration as we had and swap out malloc to G for MSE. By default, 80% of the server's memory is allocated to Varnish. And you can tune that behavior by specifying a -p runtime parameter and setting memory target to a different value. It's 80%, it could be any other percentage, but it could also be an absolute value, for example, 50 gigabytes. Varnish has dozens and dozens of metrics available to monitor its behavior, and there's storage and MSE related metrics available too. So when you go to the command line and type the Varnish stat command, you'll see the values of those metrics. We're currently on an empty cache, and you can see that the main.g_mem_rss counter has 233 as its value, which means the total memory footprint of Varnish is a little over 233 megabytes. Knowing that 80% of the cache is available for storage, mse.mse.g_space, representing the amount of free space on the system, equals 6.08 gigabytes. But that's on an empty cache. So when we start refreshing the page and filling up the cache, you'll notice that the number of objects increases. The value is 269. That's the amount of objects in the cache. But on an empty cache, this all results in cache misses. So the main.cache_miss counter is also set to 269. And when we scroll back down to the main GMRSS and the MSE related counters, you can see that the memory footprint has increased to a little over 259 megabytes, and the available space has dropped from 6.08 gigabytes to 6.06 gigabytes. The next feature we're going to do a deep dive on is tag-based invalidation with soft purging capabilities. And to do that, we first need to look at the current implementation. If you're combining Magento with the use of Varnish Cache, you've probably seen VCL code like this before. We're hooking into VCL receive to intercept incoming requests. Specifically the ones that have the purge request method, which is a custom request method used in the industry to indicate that cache invalidations are required. And this is what Magento will do. It will connect to Varnish to perform cache invalidations. To ensure that whoever connects is allowed to do it, we need an access control list. So we're checking whether the client's IP address matches an access control list called purge. This ACL contains host names, IP addresses, and subnets of authorized clients. When the client doesn't match any of the available IPs, hostnames, or subnets in the access control list, we return a synthetic 405 method not allowed error. We also expect there to be an Magento tags pattern request header or an pool request header as part of the purge request. If that is not the case, a 400 error is returned with the appropriate message. Magento tags pattern is a header that is set by Magento and that contains the invalidation pattern that should be executed, containing certain tags. Pool, however, has no relation to Magento whatsoever and apparently comes from the Capistrano deployment tool, and yet it still ended up in the official template, which makes no sense in my opinion. However, when Magento tags pattern is set, we will perform a ban execution. So by calling the ban function, we're adding the expression to the ban list. This expression is matched to all the available objects by the ban lurker thread and will eventually remove the matching objects. It does so by matching the Magento tags response header that is stored in the object to the pattern. And when that is done, 200 purge is returned. Here's an example of such an HTTP request to perform purges. It starts off by using the purge request method and then needs to specify a resource. It uses slash for the homepage, but it doesn't really matter since the URL will not be used. The Magento tags pattern contains the regular expression pattern, which ultimately tries to match the cat_p_1 tag, but since it's a regular expression match, all the extra stuff is needed as well. The response you'll get from Varnish uses the standard synthetic template, which has a bit of HTML in there, and that says 200 purge along with some other content. If you want to invalidate the entire cache, it's not really required to specify any tags, simply adding .* will match every object and will empty the cache completely. So let's see how that works when we actually run it in our test setup. So we go to our admin panel and alter the properties of one of the products. In our case, it's the first product we found, which is the Joust duffel bag. Already set it to plural bags. We're going to set it to singular bag and press save, which will trigger a cache invalidation. We can monitor these cache invalidations by checking the logs. By calling varnish log and adding a filter that only displays transactions with a purge request method, we'll quickly see the one that we triggered. It starts off with purge as the request method, it uses slash as the request URL, and then you'll see the Magento tags pattern request header that Magento set. It contains cat CP3 and cat CP4, and that's just one of the invalidations that took place. You also see that the ACL is matched and that the purged response is returned. When we call varnish adm ban.list to see the bans that are executed, our ban is added at the top. Now that I've introduced you to the inner workings of cache invalidation in Magento with Varnish, I need to explain what the problem is with this implementation. It relies on the ban function, and the ban function is not necessarily fast. Now at smaller scale, it's not a problem, but it's actually a permutation between the amount of items on the ban list and the amount of objects it needs to evaluate, and it's a permutation. So the bigger the ban list, the bigger the number of objects, the slower it will work. And because there's no soft purging, matched objects are removed from the cache, which pretty much penalizes the next user. And that's where we need actual tag-based invalidation with soft purging. And we'll do that using our proprietary YKey module. Instead of using bans, we're going to start using the purge header function of the YKey module. It takes a collection of tags, and the second argument is the separator. So in this case, we're separating the different tags using a space. And by default, there is no soft purging. It is set to false, which is the equivalent of doing a ban or a purge in Varnish, which will remove the object from the cache. But by setting it to true, we're applying soft purging. And as I explained earlier, soft purging is nothing more than resetting the TTL of a collection of objects to 0 to mark them as expired, and then relying on the remaining grace value assigned to these objects to serve stale content while performing asynchronous revalidations. The standard value in the Magento VCL is setting the grace value to 3 days, so 3 days past the TTL, the objects will probably still be around. While I did keep the X Magento tags pattern request header as the source of input, we won't really be using that anymore because it's littered with regular expression syntax. And don't forget, YKey supports actual tags, and you'll need to set them. So in VCL backend response, instead of abusing the X Magento tags header as a way of matching it with ban, we're going to use that header and use ykey.add header to inspect the header and use comma separation to catch the individual tags. And of course, in order to match everything, we'll also specify an explicit key called all, which we can match later on. This is what the refactored VCL looks like. The first thing we do is import the YKey vmod, but we still have our good old access control list, we still intercept purge request, we still enforce the access control list, but where I've changed things a bit is I removed every notion of xpool because again, it's not related to Magento. And I also took away that limitation where you get an error if you don't provide the X Magento tags pattern. In our case, when you don't provide that input, we're going to do a native purge in Varnish, which will invalidate whatever resource was called. So in this case, the URL and the host header will be used to identify that single object we're going to remove from the cache. Again, not related to YKey, but still very easy to perform one-off cache invalidations. In the next step, we're going to trim off all the regex syntax from the X Magento tags pattern and store it in X YKey purge. We want to end up with nothing more than a collection of space separated tags and no syntax of regexes. We also want to replace dot asterisk as a pattern with all, because earlier we specified an all key, we can replace that. And when we're done, the X key purge header contains a clean collection of tags that we can then invalidate using YKey purge underscore header, using a space separator to identify the tags, and then set it to last argument to true to enable soft purge. And when we're done, we can return the number of objects we matched through a synthetic 200 response. So you've seen the examples before using the ban syntax. Let's go back to our test setup and look at the logs to see what happens when we actually perform cache invalidations using YKey. And let's start off by looking how the tags are actually set. And we can check the logs. There's a lot of detail about YKey in that. We will use varnish log -g request to group by requests. We are only interested in the backend request, hence the use of -b. And -i will allow us to only include the backend request URL and the YKey tags. And of course, a very specific backend response header called X Magento tags, because those will be extracted from the tags header. And we'll do that only when the backend request URL is /, so we can see what happens for the homepage. And when we run it, we can see the X Magento tag headers with all of its tags specified as a comma separated list. But also you can see how YKey responds to it, and it stores all the individual keys. At the other end of the spectrum, we can also monitor purges that are executed by Varnish and see how our implementation and how YKey behaves to that. We try to capture all the requests that have the purge request method, and then we're including the X Magento tags pattern header that Magento will set, and we're also interested in the X key purge header that we will create. And we're interested in all the YKey headers, the response status and response reason. So when a cache invalidation happens, you can see that we start off with this typical regex pattern. But the different occurrences of reg sub all in our VCL code will slowly take away all of the junk. And in the end, the YKey logging header shows that we have a key called cat p1. And 2 objects that matched that cat p1 were invalidated, along with a bunch of other things. So you can clearly see how our VCL code turned our typical ban-oriented Magento tags pattern into something that really works well with YKey. And the metrics we capture also allow us to see the direct impact of soft versus hard purges. So when we call this varnish stat command and filter on specific metrics, we can see that there's nothing in the cache, and eventually we'll fill up the cache. So the number of objects goes to 130. Initially we start off with 130 misses, and then the hits start increasing. But when we perform the cache invalidation, the amount of objects will drop back to 0 and then eventually fill up again. So that's not good. That's what we're trying to avoid. So let's compare that to soft purges and again look at the metrics. The scenario is the same. We start off with an empty cache that eventually will get filled up and will have an equal amount of misses than the number of objects in the cache. Later on, cache hits start increasing because requests are happening on cached objects. As soon as we start executing the soft purge, Y key purges increases again to 1, but the number of objects doesn't decrease. However, as requests start entering, we see that the hit grace counter increases, meaning we did get a hit, the content was expired, but there was some grace time left, so we're doing asynchronous revalidations. And that's how soft purges can be monitored. I've mentioned it before, and I'll repeat it again, soft purging really relies on remaining grace value for it to be effective. And we have been setting it to 3 days as a default value, but you can even monitor that. So let's have a look at the logs and see how this grace value is being set. We'll run a very specific Varnish log command that only includes backend transactions, meaning communication between Varnish and Magento. We're interested in the URL, and we're interested in the cache control header that Magento returns, as well as some logging tags related to setting the TTL in Varnish. And we'll only do this for the homepage. So when we capture the logs, you can see it's for the homepage. And a cache control header was returned by Magento, which has a max age directive that is set to 86,400 seconds. And that is the equivalent of a full day. In the TTL log tag, we can see that this is the TTL that is set based on an RFC, meaning it's an official conventional cache control header. But the default value in Varnish is only to have 10 seconds of grace, and of course 0 seconds of keep. But because we've set the bresp.grace in VCL to 3 days, all of a sudden there is an override happening. And that's how we in fact end up with so much grace that we can use for soft purges. The last big feature I want to talk about is dynamic backends, and I mentioned it earlier that the standard implementation in Varnish is to perform DNS resolution at compile time. That means this magento.example.com hostname that is part of our standard backend will only be resolved to the IP address once. So when the IP address would change in the process, when DNS changes occur, Varnish would be oblivious to it. So we've refactored the VCL that will be used for Magento to include these dynamic backends that leverage the active DNS and UDO vmods that are only available in Varnish Enterprise and will be initialized later in VCL init. We'll create an active DNS group and a UDO director named Magento. This director will later be used as soon as a fetch takes place to set the backend. We'll take whatever backend comes out of this Magento UDO director. And since we can perform DNS-based load balancing, that might change every time we call it, depending on the algorithm we choose. When you isolate the code from the VCL init subroutine, you'll notice that we're creating a DNS group using the active DNS vmod. It's uninspiringly called group, and we resolve the magento.example.com hostname. But we're already forcing port 443 to be used later on. And while this active DNS vmod is used for dynamic DNS resolution, there are still some TTL rules we can enforce or abide by. Every DNS record has its built-in TTL, and we can choose to force it, meaning we're not listening to whatever is happening and we're setting our own DNS TTL. Or we can choose to abide it, or only set our own if it's more than whatever is returned, or only set our own if it's less than whatever was being returned. We'll stick with forcing the TTL and we'll set the DTL to 5 seconds, meaning DNS resolution will only happen every 5 seconds. The goal, of course, is to associate backends and health checks with this. So we can set a backend template and we can set a probe template. And when we go back to all the code, you'll notice that there is a default backend that will be used and it has 0000 as its IP address. However, it also has SSL enabled, and that is what we need. There's also a health check that points to the standard health checking endpoint for Magento. Then we create a director object using the UDO vmod, and we call that object Magento. If whatever is being associated with the UDO director has multiple backends, we'll iterate over them in a random fashion. However, we can also choose to use a fallback mechanism where we use a primary backend, and when it's unavailable, the secondary is being used. A third option is using hashing, meaning that a consistent hashing algorithm is used to distribute. However, we're not assigning these backends manually. Instead, we're subscribing to an active DNS group. So whatever the resolution is that happens at the DNS level, we'll take whatever IP address comes out of it and assign it. And this could be more than one IP address. So whenever a fetch needs to be made and magento.backend is called to get a backend from the director, one of these backends will be selected. So if multiple IP addresses were returned by active DNS, we will cycle through them in a random fashion. However, when something goes wrong and we get a backend error, we can still opt to retry, which will take another backend in the collection of backends that is part of this Magento director. Let's use this knowledge about dynamic backends and apply it to our Magento Docker setup. Varnish Stat has specific counters for dynamic backends, and this is what they look like. You'll notice that there's a VBE boot udo Magento metric there. Magento is the name of the udo group we created. And between brackets, and it's a bit chopped up, but if you go lower, if you look lower, you'll see the complete value. It returns the IPv4 address along with the port. So in our case, that's 172.18.0.7 on port A443. And we're checking the happy field. Is this server happy? And the answer is true. It is happy, it is healthy, and you can see the amount of traffic that is moving through it and the amount of requests that are being received by it. As I mentioned before, it also supports DNS-based load balancing. So if we bring up a second app, you'll see that we now have a 172.18.0.3. There's two instances of Magento we're sending traffic to, also on port 8443. The health checking is still taking place, but after a while, that one will also start receiving traffic. And if you remember correctly, there is random-based distribution there. So requests will randomly hit IP7 and IP3. Just for you to see how that works from a hostname perspective, that IP7 is what is being returned by app.docker. If we run it again, you will see that app.docker, the hostname that I'm using, is now returning 3, and that's the randomness that is part of that distribution. Our active DNS and UDO vmods have only leveraged A records. In DNS terminology, an A record is an address record, meaning a host name will be converted into an IP address. And there's other ones that are supported by active DNS as well, such as the AAAA or Quad A record that converts host names into IPv6 addresses. But there's one record type I'm particularly interested in and want to show you, and that's the SRV record, which is short for service, and that's a service discovery type. Let's see what that looks like. We can perform DNS resolution on the command line using the dig command. And we can say that we're interested in seeing SRV output for this very hostname. It may look a bit strange in terms of formatting, but it's very conventional. It has a service definition, a protocol, and then a hostname. And in our case, two records are returned. So for the sake of active DNS and udo, those are two backends, and they reflect my Docker setup. app1.docker as a hostname will be preferred, and port 8443 will be connected to. So that's all part of the SRV record. And the reason why it's preferred is because it has a lower priority than app2. But if app1 is unavailable, well then app2.docker will be used. So those are my two Magento setups in my local Docker app. So this allows me to actually switch whatever I had in my active DNS configuration and switch magento.example.com on port 443 over to this value. And that's how that could work. Internally, the two records will be returned, the right priority will be applied, and the director object will respect it. And that, ladies and gentlemen, concludes the deep dive on the 4 features that I handpicked specifically for a Magento audience. So if you're running Magento either as a user or a developer and you're struggling with certain performance elements or with your cache, I hope these 4 features make a lot of sense. I'll repeat them again. End-to-end native TLS, giving you a centralized place to easily manage the TLS parameters and the certificates with that backend TLS support that is not available in open source. Second feature, memory governor, giving you that peace of mind knowing that the size of your cache will be scaled according to runtime requirements, ensuring that you're not going out of memory. Third one, the big one of course, native support for efficient tag-based cache invalidation with that crucial soft purge option that nearly every Magento developer needs. And fourth, which is dynamic backends, allowing you to do DNS resolution at runtime, allowing you to do DNS-based load balancing and service discovery, giving you the flexibility you need and an improved resilience and scalability strategy. So that was it for today. If you like what you hear, do reach out to us. You can contact us at sales@varnish-software.com or use the chat widget on our website. Thank you for checking out this video, and I'll see you next time for yet another video.